The diagram shows a probability distribution for a continuous random variable x, where x is normally distributed with a mean and a variance, or standard deviation squared. The distribution is symmetrical about the line x is equal to 16, which means that the mean is 16 and there's a point of inflection at x is equal to 20. That also means that the standard deviation will be 20 minus 16, which is 4. 50 independent readings of x are made. Calculate the percentage at least 30 of these readings are between 12 and 18. So the first thing to do is to write down the mean and the standard deviation of the distribution. So it means mean is 16 and the standard deviation 4, 20 minus 16, point of inflection. So for one reading, we want to find the probability of success. We need to find the probability of 12 to 18 for a mean of 16 and standard deviation of 4. Again, I like to draw a diagram. So what we're actually finding is that area there. Okay, so going to the calculator. Okay, so we'll just put up the main menu first of all. So we can do it in the statistics menu. So we go to statistics menu, let's just exit that for a minute. And then go to distribution, which is that one, and we want normal. And we want normal CDF, so it's F2. Okay, we want variable. So the lower value will be 12. Enter. The upper value will be 18. Okay, the standard deviation will be 4, okay, and mu will be 24, and if we press that, we'll get the answer. Sorry, the mean is actually 16. It's better. Okay, and then we get the answer here of 0.5328. 0.72. And the problem is we can't store it, so if we want to use it again. So if we go to the other menu, okay, what we've got to remember though, and the run menu here, okay, let's just delete everything so far. So it's delete all. So we're starting from scratch. Okay, press option, press F5 for statistics, F3 for distribution, F1 for normal. Well, and okay, we need to put the lower value in first, so that will be 12. All right, and when you do like from a left hand or right hand, put in like minus 1,000, and then 1,000, a really high number, and then 18. We actually got the two values, and they've got to remember it's the standard deviation they want next, so it's 4, and then the mean. It's that way around. Okay, and that gives me that value, and then if we now do shift answer, and we will store that in a menu, so alpha A. Okay, every time I press alpha A, it will bring that value. Okay, we'll come back to that in a minute. Okay, so writing down our answer here. Okay, now for 5 readings, okay, it becomes a binomial distribution. So let y being binomial is 50, and the probability of success will be our answer here 0.5328.072. We want the probability of y to be bigger or equal to 30, which will be the probability of 1 minus the probability of y less than or equal to 29. So if we go to our calculator again, and we go back to menu, okay, and this time we go to the statistics menu and enter. Okay, again we'll press distribution. Okay, we'll go for the binomial, and we want okay, so we want here the lower value of a binomial distribution will be 0. Okay, we want it to go from actually what we need to put in, is actually the lower value, so that will be actually 30. So let's just delete that, 30. And as we're considering 50 values, we'll go up to 50. Okay, the number of trials is 50. Now, here's where we can save a bit. If we now press alpha A for this, we've got the probability success without having to rewrite it out again. And we will won't bother saving it. Okay, and then we get a probability success of 0.292092869. Okay, just allows us to use that alpha A. Otherwise, we would have to write the whole value in. Okay, so we get 1. If we're doing it manually, we do 1 minus the probability of that. And that will be 0.2926087. So can we actually skip a step if we do it on the calculator? Okay, to 3 significant figures, that's 0.209, and that's a percentage that's 20.9% to 3 significant figures. Okay, so this has been a video to show you how to find a probability of success using a normal distribution and then use it in a binomial distribution. I hope you've understood, and I thank you very much for watching.